So it looks exactly the same as before. We just go and import the data, right? So this is exactly the same code as before. The only difference is that now I can make my life really, really easy. And I just define my network by saying, hey, it's a sequential composition of layers. And I have a whopping total of 1 layer. And I want those parameters to be initialized with a normal distribution with variance 0.01. So that's it. The interesting thing is I didn't have to specify the number of input dimensions anymore. The network is smart enough to automatically configure the amount of parameters and the sizes and everything based on the size of the inputs. So that's very convenient. So if I, rather than 28 by 28, I might have maybe 30 by 30 pixels, it'll still work nicely. By the way, this flexibility comes with a serious downside in practice. So a customer who shall not be named took one of the computer vision models that we had that were trained on 224 by 224 pixels. Right, so fairly small image net size. And they applied it to 4K images. Okay. So those 4K images created a lot of intermediate memory. We'll get to convolutional networks and so on later on, but basically their system ran pretty much out of memory and was horribly slow. I mean, it was mathematically correct, but it was a not terribly enlightened thing to do. And then we got a report that, yeah, our network isn't working. So, so be careful when you make things automatic. You can be pretty much sure that the users will abuse the interface in some interesting ways. Okay, but we're not going to do that here, obviously. Okay, so here's the softmax, and now this is the numerically stable version of it. So gluon loss, softmax cross entropy loss. Okay, we could have picked a shorter name, but you don't need to use it more than once. Here's an optimization algorithm, and a very simple one is stochastic gradient descent. It's actually doing something slightly smarter than stochastic gradient descent. It's actually performing momentum and weight clipping and so on, unless you switch it off. So it's a very smart version of SGD, but for all intents and purposes, this one's fine. Just use that. Okay. And then, well, we can go and train. And the call signature of this is exactly the same as what we had before. So, except that it runs marginally faster. You probably wouldn't be able to tell much here because the overall operations are still very straightforward. Once we go to more complex networks, we'll actually see that it does run faster. Okay. Anyway, so this is training that network in Gluon. It looks very similar. Any questions so far? Okay.